When it comes to flood openings, failure is not an option.
In October 2012, Superstorm Sandy battered the Northeast.
Storm surge forced water up and over seawalls, traveling inward with great velocity and rates of rise and fall, in some cases well above 5 feet per hour. The flooding in many communities came with directional force, as in this case moving from the east to the west. Flood openings must be on 2 different walls, and best practice approaches call for placement on the walls facing the potential flow of floodwater to allow it to flow in and out the other end of the structure. There are 2 types of flood openings acceptable to meet the FEMA and NFIP requirements today: engineered openings and non-engineered openings. This particular device is constructed with a metal frame with a metal panel, also referred to as a cover. It is sized to fit into a CMU opening roughly 16 inches wide by 8 inches high. The metal panel is designed to push inward as floodwater exerts pressure on it. So the panel pops in. However, it does not pop out as the metal panel gets pressed against the inside of the frame. On January 26, 2010, a representative of the FEMA Building Science Branch commented on this device. It appears the cover is dislodged only as water rises on the outside, in which case it does not meet the performance requirement for the automatic entry and exit of floodwaters. The performance of engineered openings shall ensure that the difference between the exterior and interior floodwater levels shall not exceed 1 foot. The FEMA representative states that there are several questions related to performance with this particular device. The American Society of Civil Engineers also emphasizes performance of flood openings in flood-resistant design and construction, ASCE 24-14. Within these standards, it states that the best means to certify performance is to test under conditions that mimic a range of rising and falling floodwaters. To illustrate what FEMA and ASCE are referring to, we installed the metal panel device in a test tank designed to simulate flooding conditions against an enclosure wall. Both engineered and non-engineered openings need to allow for the automatic entry and exit of floodwaters. In other words, they need to be bidirectional and work regardless of which direction the flow of water comes from. Here we see floodwater rising on the inside of the wall and pressing the panel against the frame for which it is installed in. Here's how the panel looks from the inside. It does not budge. Floodwater will not always activate a flood opening from the outside in. If floodwater is flowing from the east to the west, and these devices are installed in those 2 walls, they will let the water in on the east-facing wall, but the water will be trapped inside, as the west-facing wall devices will not pop outward. Looking at the side view, you can see the floodwater continue to rise and eclipse the 12-inch equalization performance standard. This failure causes the buildup of hydrostatic pressure and buoyancy forces, which can result in structural damage and potentially even worse, a collapse. In summary, does this device have a permanent net-free area exposed at all times in order to be classified as a non-engineered opening? No. Does the device allow for the automatic entry and exit of floodwaters? No. During performance testing, does the floodwater level exceed 12 inches? Yes. But it's not a good thing, it's a failure, and failure is not an option. To understand all the FEMA, NFIP, ICC, and ASCE flood opening standards, contact a flood risk evaluator at info@yourfloodrisk.com and schedule a continuing education course today.